Hello, today we're going to look at right triangle trigonometry. I'm going to take you through just how to do it. And it's intimidating, I know, at least for my high school students when I first introduced trigonometry to them, just because, I don't know, the word scares them. Usually they're in the middle of a geometry class and all of a sudden next week's trigonometry. It just sounds hard. But then after this lesson, they're like, wow, this is pretty easy. I like trig. And they don't tend to really have any issues with it until I don't know, maybe they get to pre-calc and it gets a little bit harder with the trigonometry. But for the basics of trigonometry, we're going to start with right triangle trig and go from there. Now I've got our friend Oscar here from the Sesame Street because there's an acronym I like to use with trigonometry, and that is Oscar had a heap of apples. Now, if you're familiar with trigonometry, if you've done it before, more than likely your teacher taught you to use SOHCAHTOA. And if that's what you like to use, then do it. Totally fine if you use SOHCAHTOA. I don't teach it just because I always end up spelling one of these little three-letter words wrong. And I was also taught Oscar had a heap of apples. I've noticed in teaching that, sometimes I'll get the same student later on down the road in another class like physics or pre-calculus or something that had me for geometry. And if I taught that student, then they use Oscar had a heap of apples. If they had another geometry teacher, usually they taught SOHCAHTOA, and that's how the student wants to do it. We tend to like to do things the way we were taught, just like with other algorithms we've talked about in this class on adding or multiplying. We still tend to fall back on the ones in the way that we were taught it, which is totally fine. I don't care if you do it a different way. So you write out Oscar had a heap of apples. I've highlighted in red over here on the left side the way that should be written out. And that's going to equal some fractions for us. So if we look at it like this, the red letters stand for the sides of a triangle. We have Oscar had a heap of apples. And then these are actually ratios in a right triangle. So let's pull out a right triangle. There's your right angle. And I'm going to call one of the angles theta. So that right there will be the theta. Now, if you were to zoom in on it, it looks like this right here. That's it typed out. It's just a Greek letter, and almost always in math it's used to represent an angle. So even with my high school students that are just learning this, I use theta. Some teachers will use x. It doesn't really matter. It's a variable. But I use theta just because it's weird. And I want students to stop and ask the question, what does that theta stand for? And I say, well, it's an angle. It's always an angle as far as my class is concerned. And so I want students to know that when we start looking at these trig functions, this always has to be an angle put in there, never the side of a triangle. So your angle always goes there. If you know the angle, you put the angle in there. If you don't know the angle, and it's just like a variable, you put whatever the variable is in that theta spot. So the theta is where the angle goes. Now, on this, the O, H, and A stand for sides in that triangle. O stands for opposite. H stands for hypotenuse. I believe that I wrote that right. And then this is adjacent, the A there. So here's how I want you to label the sides in the triangle. Always find your hypotenuse first, because you've done the Pythagorean theorem. You should be familiar with how to find the hypotenuse. Notice you have to have a right triangle to do the steps I'm showing you today. If you don't have a right triangle, you don't have a hypotenuse, you can't do the trigonometry here. So define your hypotenuse. There's your right angle. Go across from the right angle. There's your hypotenuse. Label it first. And then sometimes there's confusion about what adjacent means. So always find the adjacent side last. And so the opposite side is always across from the angle that you're talking about. You'll never really be trying to find or talk about the 90-degree angle. You're just looking across that theta right here. That's your opposite side. And then the only side left is the adjacent side. So it's right there. So that's how we label our sides. Now, as far as the trig ratios go, we've named each one. On any given triangle, if you're looking at theta, if you put the opposite over the hypotenuse, whatever this side length is, over the hypotenuse, you're talking about the sine in reference to that angle. So the sine of this angle is going to be opposite over hypotenuse. If you put the adjacent side over the hypotenuse, you're talking about the cosine in reference to that angle. And then if you put the opposite side over the adjacent, that's down here, you're talking about the tangent in reference to that angle. My fraction's a little bit out of place there, but it's opposite over adjacent as your tangent. Now, to set this up, I tell all my students, whenever you start a homework, quiz, test, end of the year test, anything like that, exam, always write out this. Always write out, Oscar had a heap of apples. And then some students are like, well, I don't know which one's sine or cosine. It's written right on your calculator in this order on every calculator I've ever seen. Sine, cosine, tangent. Write it out just like that. Sine, cosine, and then tangent down below with that one. So that's how you set it up. The people that use SOHCAHTOA, notice this is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. That's what they mean by that. So let's look at a couple of, just not really solving anything, but just getting used to these trig ratios. So I've got written up here opposite, hypotenuse, adjacent, just to remind you. Here's our guide over here on the left. As we scroll down, we'll see that. And so just looking at this triangle, I've labeled this angle the theta. I could have labeled this angle, nope, not that. I could have labeled this angle up here theta, but I didn't. We might see that on the next page. And so all I want you to do is go through and write out, tell me what the sine of theta is, the cosine of theta is, and the tangent of theta is. Write those fractions out. So remember, identify our sides. Across from the 90-degree angle, hypotenuse. Across from theta is the opposite side. And then the only side left here is adjacent. So if we have this guide written down, I can look and say sine is opposite over hypotenuse. So my sine right here is going to be the opposite side, 8, over the hypotenuse, 17. The cosine, looking at my guide, is adjacent over hypotenuse. So the adjacent side is 15. I'm going to write that over 17. And then the tangent is opposite over adjacent. So the opposite side is 8, the adjacent side is 15. I'm going to write it out like that. So that's just setting up the ratios. We could take it further and solve for the angles. I'm not going to do that yet. But that's basically how you set up the problem. So let's look at another one. Now notice this triangle, everything is exactly the same except for what I'm calling theta. This time I'm calling this angle theta. And so now when we label our sides, the hypotenuse does not change. This is still the hypotenuse right here. See it on the other page? 17 is still the hypotenuse. But what does change is the opposite side. Now across from theta is down here. And next to it is right here, the adjacent side, the last one to be labeled. So now when I'm talking about sine, I'm talking about 15 over 17 because I moved where theta was. So you always got to pay attention where theta is. Always label your sides. The cosine is the adjacent. And then the tangent is 15 over 8 this time. So that switched around too. So where theta is makes a difference. Now we can use trig ratios to find the lengths of sides in right triangles. So let's take a look at this one. Whenever you see a right triangle, the first reaction that I want to do is use Pythagorean theorem. Problem with this is if we use the Pythagorean theorem, we get x squared plus 10 squared equals y squared. And you can't solve that problem because you got two variables. So you need to know at least two sides of the triangle to use Pythagoras. Here, we're going to have to use trigonometry. So let's set up our problem. First thing we want to do is circle our angle and then label our side. So across from 90-degree angle is hypotenuse. Across from the 25-degree angle is the opposite side. And then lastly here we have the adjacent. So I'm going to want to have on here written somewhere in my guide so I can follow it. And really the hardest part about doing these is figuring out what trig function to use. So let's suppose we want to solve for x first. If I'm solving for x, then I want to know the adjacent side, and I know the opposite side. The hypotenuse doesn't really help me out here at all. So I need a trig function, sine, cosine, or tangent, that uses adjacent and opposite. And if we look up here, there's only one trig function that uses both adjacent and opposite. This one uses opposite, but in the hypotenuse. This one uses adjacent in the hypotenuse, but neither one uses both. This one, however, uses opposite and adjacent. So I'm going to use the tangent function. So the way I write this out is I say the tangent, and remember our angle always goes in here. What's our angle? Our angle is 25 degrees, is equal to the opposite over the adjacent. The opposite side is 10, and the adjacent side is x. Now, some students want to say multiply both sides by 10 here. We know that when we deal with fractions, if we multiply both sides by 10, that is, we're trying to get x by itself to figure out what it's equal to, you end up with 100 over x, not with x by itself. So what you want to do instead is multiply both sides by x. And you get x times the tangent of 25 is equal to 10. And here's where we're going to pause and talk about a little bit about why trigonometry works. Because I know for some of you, you might remember this from high school and be thinking, yeah, I can do this with my eyes closed. Some of you, however, might be like, yeah, I never even remember even talking about this stuff in high school. What's this weird tangent thing with something in the parentheses next to it? So this right here is just a number, the tangent of 25. It's actually a function at 25. But think about it like this. Remember angle-angle similarity when we talked about similarity in the last lesson. What this means is, notice any other triangle I draw with a 90-degree angle and a 25-degree angle is similar to this triangle drawn right here. And so what we can say is, if you put opposite over adjacent, or 10 over x, it will equal, I'll call this a and b, it will equal a over b right here because they are proportional. Since these two triangles are similar, opposite over adjacent, in reference to the 25-degree angle, will equal whatever a over b is here. So before calculators with trig functions on them became affordable or even invented, we would use trig charts to come up with these ratios. So let me show you how one of those works. If you're looking at, they've got a couple columns here on this trig chart. One says radians and one says degrees. The radians you can ignore because we're not going to do anything in this class in radians. Radians are just another unit of measurement for angles. We're talking everything in degrees. And then you have sine, cosine, and tangent. The cosecant and secant and cotangent are other trig values that we won't use in this class. So if you're taking pre-calc, you could use that then. But today we're going to look at and see what is the tangent at 25 degrees. So if you scroll down on this chart, remember our tangent column is the third one from the degrees. Right here at 25, the tangent of 25 is this value right here, 0.4663. So what that means is if we go back to this, a over b right here will always equal 0.4663 when you're talking about this 25-degree angle and this side of the triangle over this one. And so when I said this equaled a number, it equals the number 0.4663, or something really close to it. So basically what you have is 0.4663 times x equals 10. And we're going to solve that. Let's get this all out of our way. So to solve it, we're going to divide both sides by 0.4663. And that gives you, oops, not the eraser, still have that on there, x equals 21.445. So that's our value for x. Now, when I'm teaching this, I have my students use the trig charts for probably the first couple of days that I go over in class to students seeing it for the first time. However, then I switch over and we start showing how to do it on the calculator. So let's see how this would be done on the calculator. Well, let's back up a few steps and look at it right here. I've got x times the tan of 25. And so I'm just going to divide both sides by tan of 25. And I get 10 divided by tan of 25. And that's what I punch in my calculator. So let's pull up a calculator. So I'm over at desmos.com. Let's see, I think there's Scientific has trig functions. There it is, sine, cosine, and tangent. And I'm going to say, what is 10 divided by the tangent of 25? Now this is in degree mode. If you don't have this calculator here, make sure that your calculator's in degree mode. Those TID3s, the graphing ones that you used in high school, most likely are already in radian mode, which notice gives us a weird answer here. So if you get a weird answer, see if your calculator's in radian or degree mode. Now, I don't know what calculator you have, so you're going to have to look it up and figure out how to put it in degree mode. If you're really struggling with doing that, though, let me know. Being an online class, though, you should be able to use Desmos and come up with your answer here. So we get 21.445, blah, 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 all that extra stuff there. Exactly the same thing we did using the trig chart, or pretty close to it. So let's go back to this problem, and I'll go ahead and type in our answer. So x is 21.445. You can just say it's 21.4, and I'll be happy with that. You don't have to take it out to 3 decimal places. For y, the value of y here, I'm going to pretend like I don't know what x is. Yes, technically we could use the Pythagorean theorem now and say 21.445 squared plus 10 squared equals y squared. But because I did truncate some of that value off, I'm not going to get as an exact value for y as I could. And plus we're learning trig here. So I want to know what the hypotenuse is. So that means I'm going to have to use one of those trig functions with an h in it. I know the opposite side, and I'm pretending like I don't know the adjacent. So opposite and hypotenuse, the only trig function that deals with opposite and hypotenuse is sine. So I'm going to set this up like this. The sine of my angle, 25, is equal to the opposite side over the hypotenuse. Now, just like the last problem, you've got that unknown in the denominator. You're going to have to multiply both sides by y and then divide by sine of 25. Whenever the variable's in the denominator on these problems, I just tell my students to use the switchem property. It's not really a math property, it's one that I just kind of call it switchem, which means you take the denominator and whatever's on the left side here and you just switch the two. So this gives me y equals 10 divided by the sine of 25. And so there's your switchem property. If we're using charts here, let's pull up the chart again. We got 25 degrees, and the sine is this column right here is 0.4226. So using the charts, we're going to get y equals 10 divided by 0.4226. And so y equals 23.663. So 10 divided by sine of 25, we could also use the calculator. Which you still have to use a calculator for either one, but using the calculator in trig, we're going to do 10 divided by sine of 25. So let's just change this to sine. And it gives us the same answer there, actually a little bit different. So I guess our answer using the trig chart's a little bit like a 1/100th, or a little less than not a 1/100th, a little less than 1/1000th bigger than what it actually is. Using the calculator with trig is going to give you a more exact answer. But like I said, I want my students to know more of the background than just punching it into a calculator and it magically giving you an answer. I think that's a bad approach. Students need to see that we can do this because every triangle in the world that has a 25-degree and a 90-degree angle in it, when you take the opposite side and divide it by the hypotenuse, you're going to get 0.4226, or a number really close to that. That's why trig works. So let's take a look at this one. You can pause the video, solve for x and y here. So I'm just going to choose to solve for x first. Let's see, let's label our sides. This is the hypotenuse. Here's my angle. This is the opposite side. And then this is the adjacent side. So to solve for x, I need opposite and adjacent. That's going to be the tangent function. So the tangent of 64 is equal to the opposite x over the adjacent 7. Now in this case, I'm not going to use the switch-on property because the variable is not in the bottom. The variable is up top. And so now I could just simply multiply both sides by 7. So 7 times the tan of 64 is going to equal x. So punching that into the calculator, let's pull that up. 7 tan 64. And by the way, you can get Desmos, a Desmos app for your phone if you want to use your phone while you're working this. Now, if you're if you're watching this video and you're in my class at the school and just watching this video to get caught up on a lesson or see a lesson again, you can't use that on a quiz or test your phone. You can use your calculator. But if you're in the online class, you're probably taking the quizzes at home anyway, and you just use your phone if you need to use the calculator. This gives me 14.35. So let's go back to there. X equals 14.35. We're going to use trig on all this, so we're going to skip Pythagorean theorem again and solve for y. So solving for y using the same 64, I've got the hypotenuse and the adjacent side. Adjacent hypotenuse is going to be the cosine function. And so the cosine of my angle equals the adjacent side 7 over the hypotenuse y. Because the variable is in the denominator, I'm going to use the switch-on property, and I get y equals 7 divided by cosine of 64. So let's punch that in. 7 divided by cosine of 64. 15.9. We'll say 15.97 there. Oops, family again. 15.97. All right. Try this one out. So for this one, let's see, let's label our sides. Here's my angle. This is the opposite side of that angle. Opposite to 90 is the hypotenuse, and then this side is the adjacent side. So if I'm solving for x, I need opposite and hypotenuse. If you look at your little guide, that will be the sine. So the sine of 36 is equal to the opposite over the hypotenuse. Use the switch-on property, you get x equals 10 divided by sine of 36. Let's punch that into the calculator. And I get 17. And then let's solve for y here. So y is adjacent, and I know the opposite. The only dealing with adjacent and opposite is going to be tangent. So the tangent of 36 is equal to the adjacent y over the opposite 10. Multiply both sides by 10, I get 10 times the tan of 36 equals y. And you get 7.27. Here's another one to try out. So label your sides. And I should have this in here. It should be a right angle right there. But labeling the sides, this is the hypotenuse. Here's the angle. This is adjacent. Oh, I'm going too fast here. This is opposite, isn't it? This is opposite. And then the last one right here is adjacent. So I want to know what x is. I know the hypotenuse. I want to know the adjacent. The only one dealing with adjacent and hypotenuse is cosine. So the cosine of 41 is equal to the adjacent side over the hypotenuse. So 11 cosine 41 is going to equal x. Which is 8.3. Then to solve for y, let's see, I want to know the opposite side, and I know the hypotenuse. So opposite and hypotenuse is going to be the sine function. So the sine of my angle is going to equal the opposite over the hypotenuse. So multiplying both sides by 11, I get 11 times the sine of 41. So this just changes to sine. And I get 7.2. There's your value for y. So not only can trig be used to find the side values, we can also use it to find the angles. So let's take a look at how we would do that. So in this case, once again, you could find the third side by using Pythagorean theorem, but they're not asking you for the third side. They want to ask you for the angle there. So label everything you know, the sides that is, and kind of set up a trig function like you would if you were solving for a side. So here's my angle. This is the opposite side. This is the hypotenuse. And sorry for the sloppy writing. And then this is the adjacent side. Now, I don't know the adjacent side, and I'm not trying to find the adjacent side, so I really don't care about that side. What do I know? I know the opposite and the hypotenuse. What trig function uses opposite and hypotenuse? Well, the sine does. So I want to know the sine of my angle. My angle here is going to be x, and that equals opposite over hypotenuse. Whenever I'm talking about the sine in a triangle, you're talking about the angle of the side opposite the angle and divide it by the hypotenuse there. So we've got 5 over 14. Now, if I were solving this using the trig table, what you want to do is divide 5 by 14. So if I say 5, whoops, let's clear this out. If I say 5 divided by 14, I get 0.3571. And then I'm going to go to the trig table where it says underneath sine 0.3571. So here's sine, and there's 0.34, that's 0.03, that's fine, 0.3584, what was the number? 0.3571. So it looks like it's going to be between 20 and 21 degrees. You might even say 20 and a half, or actually it's probably closer to 21, maybe 20.8, 20.9 degrees. So all I'm doing is doing this in reverse. I'm dividing it out and getting a decimal, and under the sine column I'm seeing what angle matches up with that. Now the unfortunate thing about using the chart is if the angle is not a whole number, it's going to be hard to tell what the actual angle is. So how do we solve this using the calculator then? Well, let's go back to this. In math, everything has an opposite. Multiplying has division, addition has subtraction, squaring has square rooting, and here is no different. We are taking the sine of something. This is a function. Just like when we talked about function notation, we said f of x. That doesn't mean sine times x. A lot of students want to divide both sides by sine to get x by itself, but it's not multiplying here. Just like when we write out f of x, we're not multiplying, we're labeling that as the f function. This is labeled as the sine function. So the opposite of taking the sine of x is to take what we call the sine inverse, which looks like this. It's like sine raised to the -1. That's the notation for it, and it's not what it actually is going on, but it's the inverse. But just like in algebra, whatever I do to one side, I also have to do to the other side. So I take the sine inverse of this side and the sine inverse of that side. Let's see how to do that in Desmos. So in Desmos, they don't have that little bit of notation here on the main page, but if you click on function, it gives you a whole bunch of other types of functions out there. Some of them we've talked about in here, but I want to look at the sine inverse function, and let's clear out that. So let's suppose I want it, before we actually take and find the answer to this problem, to convince you, because what's going to happen here is, what happens when we take the sine inverse of the sine of x? Let's look at this. What if we were to take the sine inverse of the sine of 30? What if I punched that in? What would that look like? So sine, and well, let's type it in like this, sine of the sine, or sine inverse of the sine of 30. Notice what it equals here. It equals 30. What if I change that number to 20? Oh, it equals 20. What if I changed it to 10? Oh, it equals 10. It won't let me do an x because they're just calculating out actual numbers here. But you can see that no matter what I put in here, so long as it's in the correct domain, I'm going to get, that's basically, you can think of it as your canceling days. It's canceling out. It's the same thing as me saying this. What is 5 times 2 divided by 5? Oh, it equals 2. And everything I put in here, I could put a 30 right there. I get 30 because I'm multiplying by 5 and then I'm dividing by 5. I'm doing opposites there. So if I take the sine inverse of the sine of 30, I get 30 because they are opposites. So going back and looking at this problem right here, this would just become 30. And this up here, what would happen with this? Well, these would cancel out and I get just x by itself there. But remember, you can't just take and the sine inverse of one side. You've got to do it over here also. So we are going to say it equals the sine inverse of 5 over 14. So I go over to the calculator and I type in the sine inverse of 5 divided by 14. And I get 20.92 and some extra degrees, fractions of a degree there. So this part right here, taking the sine inverse of 5 over 14 is the equivalent of finding that 5 over 14 underneath sine and seeing what angle it gives you in here. It's just a little bit more accurate because it tells us for sure it's 20.92 there. That's our angle on this problem. 20.92. All right, pause the video and try this one out. Solve for x here. So for this one, if we label the sides, this is opposite, this is hypotenuse, this is adjacent. Hypotenuse is out. The only trig function that deals with opposite and adjacent is going to be the tangent. So the tangent of my angle equals opposite over adjacent, 8 over 5. So if I take the tan inverse of both sides, I get x by itself there is equal to the tangent inverse of 8 over 5. Let's punch that into our calculator. Tan inverse of 8 divided by 5, that equals 57.99. We'll say it's 58. So 58 degrees is my answer. Try that one out. So this one, if we're labeling sides, this is hypotenuse. Over here is the opposite side. This is the adjacent side. So the only one dealing with adjacent and hypotenuse is cosine. So the cosine of x equals 9 over 13. So x equals the cosine inverse of 9 over 13. Let's punch that in. And we get 46.2. So we got some decimals in here. That's fine. We can still work with decimals. Try this one out. So there's our sides labeled. We got adjacent and hypotenuse. The only one dealing with adjacent and hypotenuse is cosine. So we got the cosine of x equals adjacent over hypotenuse. So take cosine inverse of both sides, 3 over 5.8. And you get 58.9. Try that one out. This x is, it's hard for them to type it in here sometimes. That's in this corner right here. So this is the opposite side, this is the hypotenuse, and we don't care about the adjacent up there. So opposite and hypotenuse, that's going to be sine. So the sine of x equals 17 over 41. Take the sine inverse of both sides. You get 24.5. All right, let's try out one more here before you do your homework. So this is our x. This is going to be opposite. Across from the 90 is the hypotenuse. And last here is adjacent. So opposite and adjacent, look at their trig chart, or not the trig chart, but the trig guide there. Oscar had a heap of apples. Oh, once again, going faster than I can write. Oscar had a heap of apples. And then we have sine, cosine, and tangent. Remember, there's a theta in there. That's where your angle goes. So the only one deals with opposite, and adjacent is our tangent function. So the tangent of x equals opposite 0.34 over adjacent 0.15. Take the tan inverse of both sides. Is it 0.15? I think it was. I switched screens, I can't remember. Yeah, 0.34 over 0.15 gives me 66.2. That's our angle there. So remember, you can use trig to find the values of angles like we just did on the last few examples. We can also use trig to figure out the values of sides. Just make sure that you're labeling everything. You know, it can be real easy to try to move too fast and forget to write out the chart or the guide. It can be easy to move too fast and accidentally label a side adjacent or opposite that shouldn't be. A lot of students want to skip the labeling part just because it's, you know, they got to write a few extra letters there. Don't do that. You know, take your time with it, draw the picture if you need to, and then, like I said, I'm not making you use the chart. It's just there for your knowledge, and you can use the calculator all you want. Make sure it's in degree mode, though. Okay? Try out the homework tonight, and let me know if you have any questions. Thanks for watching, and thanks for working so hard in the class.